Hello viewers, right now we are going to learn about the derivatives. Okay, derivatives. This is the part 1 of this new video series, and in this one we'll learn it from the basics, that we learn in details how to use the formulas for each and every different types of problems that we can. So let us start with the most basic formula, which is for the derivative of, suppose if the function is y equals to x to the n, sort of a monomial, because this is a polynomial containing only one term. So what if we differentiate it? How are we gonna do it? So we can do it by using the basic formula, which is like the derivative of, we can say, x to the n with respect to the x. Always remember that d over dx is the operator, or we can write it in this way also, like just to differentiate, d over dx is the operator and our operand is this x to the n function here. Okay, always we have a function over here. So if we differentiate x to the n with respect to the x, this will be actually equals to n times x to the n minus 1. This exponent will be in the front, and then we multiply it to the x to the, and further we'll decrease the exponent by 1. So this is how this formula goes on. So we have to remember this basically as a formula, the first formula that we are going to learn in this video series, and we'll be using it in future so many times. So we can maybe remember this as formula A maybe, okay, just as a reference. So how are we going to use this thing? Always remember this n is going to be any integer, anything except -1. Okay, now you see why I'm saying that. I will clarify it later on. Okay, so now suppose if we have a question like, and one more thing. Okay, let's see this question first of all. Suppose that the question is like, if y equals to x to the 7 maybe, then find dy over dx. dy over dx means the derivative d over dx of the y, that is derivative of the y with respect to x. So to solve this problem, we will use the same formula. Like we can say, first of all, remember one thing, that we can say like dy over dx, this is same as, sometimes we say f prime or f dash x, and sometimes we say y sub 1. These are all means that derivative of the function y with respect to x. These are all the symbol, so different representations for the same thing. So different way to represent this dy over dx, okay, the derivative of function y with respect to x, because we know y is same as fx. Okay, y is same as fx, so we can say that the f prime is, we have differentiated it once. Now let's go back to the problem. So the problem here says that y equals to x to the 7. Y equals to x to the 7. So if we differentiate this function, that is we want to find dy over dx, derivative of the function y with respect to the x, that will be derivative of the x to the 7 with respect to the x. So we replace the y with the x to the 7. Maybe I should just change the color so that we can differentiate, or it's just better to look. Okay, let me use the different color, like let me use the x pink color maybe. So this is, now the function is here x to the 7, which is the operand, and the operator is this d over dx. Okay, now when we differentiate, when we apply this formula, like derivative of the x to the n with respect to the x is what? The same formula we wrote earlier, derivative of x to the n with respect to x, this is equals to n times x to the n minus 1. So here instead of n, it is 7, so that is 7 times x to the 7 minus 1. We just replace the n by 7, so that's it. Now 7 minus 1 is 6, so that is x to the 6, so that is 7 times x to the 6. So we can say like derivative of x to the 7 with respect to the x, or which is same as derivative of the y with respect to the x, this is equals to 7 times x to the 6. So this is our result. Okay, this is a very simple example. Now Let us see a different problem. Maybe if we say another function, like suppose if we say y equals to maybe x, okay, just a simple function x, then what is the derivative of the this function y equals to x? Actually, this y equal to x is a special function which is also known as identity function. Okay, anyways, we don't go into that details. Let us see how we'll find the derivative of the x. Okay, so we can say y is equal to x, this is given, okay, and we can say x is same as x to the 1, because when there's no exponent here, that means the 1 is there in the exponent. So if we derivate this function, so we can say derivative of the y with respect to the x, which is derivative of what is y is x to the 1. So derivative of this x to the 1 with respect to the x, okay, this is also okay. You can also write derivative of the x. This is same, both are same notations. Just to have a better look, I just wrote it like that. Okay, so now you see n here is 1. So when we apply that formula, the same formula that I wrote over here, derivative of x to the n with respect to the x, this is equals to what? N times x to the n minus 1. So when we'll use this formula, we can say n equals to 1 here. So I'll just replace n by 1. So that is 1 times x to the 1 minus 1. Okay, I replace the n equals to 1 here and there. Okay, so that is 1 here and 1 there. These two are the ones now. So when we simplify this thing, that is 1 times, this is x to the 1 minus 1 is 0. And anything to the 0 is actually 1. So that is 1 times 1, and 1 times 1 equals to 1 only. So from here we conclude that the derivative of the function x with respect to the x, or we can say dx over dx, that is equals to 1. Okay, this is like one of this, we can say, derived formulas. This is not actually the formula, but we are going to have this situation several times, like we are while solving questions we'll see it several times, like we'll come with this function x and we'll have this expression. So whenever we see x anywhere and we have to differentiate that x, so we don't need to apply this formula directly. We can say that this is simply 1, derivative of x with respect to it, this is 1. And this also can be assumed by the logic or common sense, like sort of see dx over dx, same thing in the numerator and denominator gets cancelled, so that is simply 1. So that's another way to think about it, but the most or the theoretical approach to prove it using the formula is like this. Okay, and let us see one more. Maybe actually I said in this video that x in this formula n can't be equals to -1, but I think I should take my words back, because I'm sorry, I feel if x is even -1, then also we can use this formula. Let us see. Or basically if it is any negative value, negative integer or positive integer, this formula is true for all of those values. So let us see that, okay, how we can use one more example. Okay, one more simple example for that. So suppose if the question is like, if y equals to 1 over x, then find its derivative. Okay, find dy over dx. So if y equals to 1 over x, then what is its derivative? So in the solution we can say given is what? The function y, which is equals to 1 over x. Since y equals to 1 over x, we can write 1 over x as x to the -1. Why? Because 1 over x is same as 1 over x to the 1, and we know a property or a formula. You can say what is the property, but 1 over x to the n, this is same as x to the -n. So if we see here, that is x to the 1 here, so if we bring this in the numerator above, so that is x to the, this exponent will be negative just. So the negative of the 1 is -1. Like here we did the negative of the n, which is -n. So likewise, so we can say like, oh, the 1 over x is same as x to the -1. Now we can go into the derivative part. We can say like derivative of the y with respect to the x, this is equals to derivative of 1 over x with respect to the x, because y is equals to 1 over x. And now we can replace this 1 over x by the x to the -1, because we already know x equals 1 over x is same as x to the -1. So we are differentiating x to the -1. So instead of n, what is here? If we use the same formula that we learned earlier, that we saw earlier, that the derivative of x to the n with respect to the x, this is equals to n times x to the n minus 1. So n is equals to -1 here. So we can apply the same formula and say that derivative of this x to the -1 will be -1 times n times, which is n is a n times x to the n minus 1, but n is -1, so x to the -1 minus 1. So we replace the n by -1 here, okay, you see. So now when we simplify this thing, this will be -1 times x to the -1 minus -1, sorry, -1 minus 1, this will be simply -2, okay, -2. So now we can say this is same as -1 times, and we can convert this using the same property in the reverse way, like x to the -n is also equals to 1 over x to the n in that way. So we can say this is equals to 1 over x square, and now we can multiply. So x to the -2 is 1 over x square, okay, because this is -2, and when it comes in the denominator we take its opposite. So since it's negative, so it will be positive, okay. So -1 times 1 will be -1, and in denominator will be x square. So we can say from here that derivative of the 1 over x with respect to the x, this is equals to 1 over x square, and this is like one of the other derived formula which we'll generally use like a formula, but it is not actually a basic formula, but it can be considered as a derived formula, okay, derived formula, which we will be using several times in our future videos. So I hope you are following it, and if you have any comments or any doubts or any questions, you can ask it in the comment box, and I'll try to answer those as much as possible, and we'll meet in the next video hopefully. Bye bye, till then, take care, thank you.